Okay, so we are on Thursday night's homework here, March 5th, and this one is open-ended. It is 5 problems, but it is getting you ready for your next day of STAR review tomorrow. So as you go in, if you have questions over these, be sure and reach out and ask the teacher, no matter what class you're in. But this is your reminder that tomorrow we are in the alternate rooms for your STAR review. So some of you may be in your normal classroom, but not everyone will. All right, the water levels are listed for 5 lakes. We want to put them in order from most full to least full. So that means greatest to least. Okay, so we'll have to remember that at the end. Anytime you see numbers like this, let's just put them on a number line. Okay, that makes it easiest. So, or make them all decimals first. Okay, so this is a decimal. Okay, negative 1/2 is negative 0.5. This is positive 2.1. Uh-oh, negative 8/4. What's 8 divided by 4? 2. So that's at negative 2. And positive 2/3. And this is already negative 0.75 feet. Okay, well that's pretty easy. Actually, we didn't have to really do much there at all. Okay, negative, they have both of these that are in the negatives between 0 and negative 1. So we need to be very careful about where we plot them. Okay, which one is closer to 0? 1/2 or 3/4? 1/2 would be. So my negative 0.5 would be right here. So this is actually listed as negative 1/2. Then Joe Pool Lake right here at negative 0.75. Okay, we have a negative 2 over here that shows Possum Kingdom Lake. I'm going to put PK here. And that is negative 8/4. We have positive 2. That's, oh, actually, nope. That is, I did not label this right. It's not Possum Kingdom. That's Lake Ray Hubbard at negative 8/4. Possum Kingdom was over here at positive 2.1. And Lake Whitney is up 2/3 of a foot. So that's between 0 and 1 whole. Okay, so when I go greatest to least, I'm going to have 2.1 first. So this is Possum Kingdom is first. The second greatest one is the 2/3, so it's Lake Whitney. The third fullest is negative 1/2, and that is Lake Louisville. The fourth is negative 0.75, so that's Joe Pool. And the last one over here is Lake Ray Hubbard. Okay, a lot of times people get so mixed up and frustrated with looking at the decimals in here and the fractions that we don't even pay attention to the negative, which ones are negative and which ones are positive. And so I didn't actually have to do much math here at all, as long as I use some reasonableness and use the number line. It really helps. Okay, next, let's put these numbers in order from least to greatest. Oh, okay, I have a negative 4, a couple of negative 3s. Oh, I don't know what that is. So I need to figure that out because I can't compare this when they look differently, right? So 17 divided by 5. 5 times 3 is 15. I'm going to subtract and get a 2. Now here's the choice you have to make. Do you want to make them fractions or do you want to make them decimals? I say decimals a little bit easier because I don't have to get a common denominator. So if I'm going to make a decimal, I add my decimal there. My 0 goes underneath this line, not above it. Now 5 times 4 is 20. So this is negative 3.4. Uh-oh, what is 5/8 going to be now? I have a 3.2 and a 3.4. Where does that one go? Well, that means I need to divide. 5 divided by 8, that's more than 1/2, right? Okay, 8 doesn't go into 5, but 8 goes into 50 6 times. 6 times 8 is 48. I get a 2. Let's keep adding my 0 and dividing. 8 times 2 is 16, and I get a 4 and a 5. So this is negative 3.625. Now, when we have our decimals, let's line them up. Negative 4.000, negative 3.200, negative 3.625, and negative 3.400. We want least to greatest, but when they're all negative, the one that's going to be the smallest is the one that looks the biggest. So this is my least. This is my least there. Okay, now what next? The one that looks the biggest is this one, negative 3.625. So it is negative 3 5/8. Okay, then the 3.4, so that's negative 17 fifths, and then negative 3.2. And that is my answer. But this is how you prove it. You line up your decimals, you make them all decimals, okay? Oh, I love this problem right here. Name a value, that means a number, that is between 1.5 and 16 tenths. Okay, and actually, those numbers are a lot closer than you may think. So let's make this into a decimal. So 16 divided by 10. Does 10 go into 1? Nope. Does 10 go into 16? Yeah, one time. 10 times 1 is 10. Subtract and get a 6, and I add my 0 here. I bring down this 0, so 10 goes into 60 6 times. 10 times 6 is 60. So, oh, this is 1.6. So I need a number that's between 1.5 and 1.6. And you may say, well, there's not anything. There's nothing between 5 and 6. Well, not in the tenths place. But what if I add that? What is between 1 and 50 hundredths and 1 and 60 hundredths? It could be 1.51, 1.52. It could be 1.579. It's a 1.5 and anything. Okay, that is up to you what you choose to put in there. You could add zeros as long as you want and pick a number in the middle. Okay? Next, negative 3/8 and negative 5/10. We're going to use less than or greater than symbols to compare. A lot of us are still getting mixed up on our less than and greater than symbols. I noticed that grading the test last week that we may in words say that it's less than, but we are still getting mixed up with our symbols. So remember, less than, you can take that less than symbol and write out the L for less than. Okay, and greater than, that may help you remember that a little bit more, okay? All right, so now let's make them both decimals. I cannot compare eighths and tenths. That's like comparing pizza slices that are cut into eighths or tenths. They're not the same thing. So I need to make them decimals. So 3 divided by 8. Well, I know that when I'm dividing by 8, there are always going to be 3 decimal places because there just are. 8 goes into 1,000. 8 doesn't go into 3, but it goes into 30 3 times because 8 times 3 is 24. And I subtract and get a 6 and bring that down here. 8 times 7 is 56. And I get a 4. And I bring down another 0. So 8 times 5 is 40. So this is negative 0.375. And this is negative 0.500. Okay, so they're negatives though. I'm looking at 375 thousandths and 500 thousandths. But they're negative. So the one that looks bigger is actually going to be smaller because you're on the left side of the 0. So this one is actually bigger, this left one here, okay? All right, last one for us. Okay, we're going to put these in order from greatest to least. Man, so often we read that and we circle it and we still don't go back and check that we did the right order, okay? So I have a 5, I have a 4, a 5, and I don't know. Let's see. 12 divided by 5. 5 times 2 is 10. And I have 2 remaining. So I'm going to add a decimal and a 0. 5 times 4 is 20. Okay, so this is 2.4. So I have this one right there is 2.4. Well, let's check. They're all positive. So if I'm going to write them out in greatest to least, which one do I know is the smallest? 2.4, right? That is definitely the smallest, which is also 12 fifths. Okay, now I'm going to mark that out here in green because I know I'm done with it. Okay, what else do I know is going to be the smallest? Look at the whole numbers first. There's a 4 in here, so 4 and 3/5 is the next smallest. Okay, so our numbers are getting bigger. I have a 5. 5 is going to be smaller than 5 and anything else, right? So that one's done. Okay. Oh, now I can look at this and say 5 2/3 or 5 2/100. Now you could picture what 2/3 looks like. 2/3 of a pizza is a lot. But let's say I'm going to cut this pizza into 100 little slices. And I'm going to give you 2 of them. How tiny? I can't even draw that. Look how tiny they're going to be, right? 5 2/2 is way smaller than 5 2/3. Okay? Because 5 2/3 will be 5.66666. Okay? So that right there, I really didn't have much comparison to do, except for really those last couple. Okay? All right, thank you. Don't forget, tomorrow when you go in, you're going to turn this into the first teacher that you go to for your star rotation.